Okay, so here we are again. I'm going to be doing problem number 3. Someone asked me to do that one. They came up with a different answer. And what I didn't do yesterday, and another student reminded me of that, is problem number 5, which will take a little longer to do. I took the liberty of setting up problem number 3 here. Notice I just plugged in the numbers, and there it is standing right in front of you. Well, there are different ways to do this math. Lots of people could do it different ways. There are 3, 4, 5 different ways to come up with the same answer. So if I'm doing it different ways, you could get the same answer doing it another way. Well, I could get rid of the 3's this way, but I'm going to lower the numbers a little bit because 3 goes into 12 4 times, and 3 goes into 6 2 times. So I'm trying to stay organized, and I might as well get rid of the pi's because they cancel as well. All right? So there I am, and now your average 8th grader should consider rewriting. And what do I have? I have a 9, and a 9, and a 4 on the top. Nothing else as far as I can see. And what do I have on the bottom? I have a 6, and a 6, and a 2, and there's that 4 from before. So I check again, the 4, the 6, and the 2, which became 2 because it had out there. Well, goodbye, that's an easy one to do. This becomes 3 over 2, there's your 3, there's your 2. This becomes 3 over 2, so what's left? 3 times 3 is 9, 2 times 2 times 2, that is 2 cubed, is 8, and that's the answer I believe I posted yesterday. Okay? So, I see that you can't see that part, but when I put the 3 times the 3, 3 times 3 over here, and 2 times 2 times 2 over here for the weaker students, you can see that it comes out to a ratio of 9 to 8, which is roughly 1 to 1 in a practical sense. So I'm going to quickly erase all this stuff. And trying to fight the clock, so to speak, with these video things. And this was homework number 5, a bit more challenging than the one I just did. I'll get over here because I'm trying to avoid getting in the way. And the problem is asking you the following. You have soup cans that you buy in the supermarket. And this is the size of the regular. The diameter is 10 centimeters, and the height is 18 centimeters. And then, of course, the family size, where the diameter is 12 centimeters, and the height is 24 centimeters. So the first question asks you, which has greater volume, 2 regulars or 1 family? So it's pretty obvious what to do. I'm going to calculate the regular, and then I'll calculate the family. So calculating the regular, since I'm calculating 2 of these, I want to know which has more volume and by how much. We'll get to that in a second. I have the numbers here. Since the diameter is 10, the radius is going to be 5. So I have pi times 5 squared. Again, just a lot of plug-in problems in this math, although it's really not that easy sometimes. Okay? And when I pursue this, I get pi 6 squared. Let's see, what do I have here? Pi. Then I end up over here working sideways. I get 2 times pi 25 times 18. And then when I multiply everything together, I'll let you do those honors. I get 2 times pi times 450. What I mean to say is that 25 times 18 is 450. You can do that on a calculator. And so the 2 regulars, when you do the math here, is 2 times 450 is 900 pi. So we have to compare that with the volume that we're going to get for the family size guy. So the dimensions are a little different. Careful with the diameters. Half of 12 is 6. And so when I plug this one in, I get pi 6 squared times 24. Okay, everybody see that? And then I multiply that out. That's 36 times 24. Feel free to use your calculator, and I get 864 pi. And so obviously, 2 regulars gives you a bit more, not a lot, than the family size. But remember, typically 2 regulars will cost quite a bit more than a family size in a supermarket. Okay, so here we go. Now, so the difference, by the way, is 900 pi minus 864 pi. So the difference is 32 pi centimeters. And I've noticed on the work that kids have turned in, they turn this into 3.14. And for the scientist or the engineer who needs to know precision, that's exactly what would happen. So now we go to the second part of the problem, and I'll have to erase this really quick. Again, I'm trying to avoid blocking your view as I'm working. And here we go back and we write all the things that we knew before them. Okay? So we have pi 6 times 6 times 24. That's the big guy. Okay? Those are the dimensions. There's the 24. There's 6 squared. So I wrote it out because I did all the work already. And now one little guy, it states, and you want pi times 5 times 5 times 18. Okay? So there we are again. We seem to be doing the same thing again and again. So the pi's cancel, and there's certainly some action here. 6 goes into 18 3 times, and 3 goes into 24 8 times. But as you notice, the rest of the numbers are coprime. 6 times 8 divided by 5 times 5. As I've mentioned so many times in class, 6 is 2 times 3. 8 is 2 times 2 times 2. They never cancel with the 5s. So the proper answer here is the ratio of the family size to one regular size is 48 over 25, which is about 50 over 2, which really makes it roughly 2-to-1 ratio, although this would be the proper answer, and you could put it into a calculator, although this would tell me much more than a calculator. Okay, so I did both of those problems. I'm running up on 8 minutes. Hopefully I explained them properly. Keep in contact with me, and I'll be happy to do more videos. I have some more on the way. I'll be doing the assignments that I gave you yesterday. Okay, let me post this.